Hello and welcome back. Today we're going to talk about chemical compounds and how to read some chemical formulas and what sort of information you can get from them. And we're going to finish off today by talking about ionic versus molecular compounds. This is the start of topic 3. You can determine how many elements are in a molecule by looking at the subscript that directly follows that element's symbol. Subscripts are the little numbers after an element. This word after means to the right. So if you see the word after, to the right. Maybe you grew up reading from right to left, and so after you might think is to the left, but after means to the right. Let's take a look at this formula here. This is the formula for water, H2O. It's telling us the types of elements present in the molecule and also how many. So this is the symbol for the element hydrogen. This subscript here modifies hydrogen. So the subscript here modifies the hydrogen. It tells us that there are 2 atoms of hydrogen. This is the symbol for oxygen. If there's no number, it doesn't mean 0, it means 1. So there's no subscript to the right of the oxygen. So it means there is 1 atom of oxygen. We also throw in the state of matter with a letter. So the small letter here means that this is a liquid. You might see a couple other ones. If you see an S, that means a solid. If you see an L, we've just said that here, but we'll write it down. That's a liquid. If you see a G, that means it's a gas. And if you see an AQ, that stands for aqueous, but it means dissolved in water. Dissolved in water. This is a diagram of what a water molecule looks like, and you can see there is an oxygen atom attached to 2 hydrogen atoms. And if you decide to take Chemistry 20, you'll spend a long time drawing these sort of pictures and knowing the shapes of them. But for Science 10, I want you to focus on reading and writing these chemical formulas. If you take a look at this compound here, this is carbon dioxide. If you're looking at it, we've got carbon. There's no little subscript. So if I'm zooming in here, there is no subscript. That doesn't mean 0, but that means 1 carbon. This 2 applies to the oxygen. That means we have 2 oxygens. If you're looking over on the side here, how many atoms total are in a molecule of carbon dioxide? Well, I've got 1 carbon and 2 oxygens, so I have 3 total. That's just 1 plus 2. Some of these compounds are going to have a little bit more complexity to them. If you look at this one here, we've got brackets. These brackets are showing you that this 2 doesn't just apply to the hydrogen, it also applies to the oxygen. The subscript applies to everything inside the brackets. Would be different if it was calcium, oxygen, and just a 2 after the hydrogen. If there was no brackets, then this 2 would only apply to this hydrogen. But this is not the case, and that's not correct anyways. But if we're looking here, this 2 applies to the things inside. There's no little subscript to the right of the calcium, so we have 1 calcium. And this subscript applies to both the oxygen and the hydrogen, so we have 2 oxygen and 2 hydrogen. And so if we are adding up how many atoms in total are in each of these compounds, this one is called calcium hydroxide. We would add up 1 plus 2 plus 2. That's 5 atoms total. I'm going to take a look at this table here, and we'll have some practice counting the number of atoms in these. Calcium carbonate. This is used as chalk. Here is our chemical formula. We've got calcium, carbon, and oxygen. Don't get confused. This is not cobalt and 3 cobalts. This is a capital O, so this is oxygen. This is not 3 cobalts. If we're looking here, we have calcium. There's no number, no little subscript, which means we have 1 calcium. Carbon, no little subscript, so 1 carbon. This 3 applies to the oxygen, so we have 3 oxygen. The total number of atoms, 1 plus 1 plus 3, is 5. On the next page, there's some practice here. I'm going to invite you to do some practice, try these out. So pause the video, try these out, and I'll do the monosodium glutamate with you just to give a little bit of practice here. So if you've paused the video and you've tried it, then we're going to work through this one here. There's a lot of elements in this. Sodium has no little subscript, so we've got 1 sodium. Carbon has a 5, so we've got 5 carbons. Hydrogen has an 8 to the right of it. Nitrogen has no number, which means it has 1. And oxygen has a 4. So if we're adding up the total number of atoms, 1 plus 5 is 6. 6 plus 8 is 14. 14 plus 1 is 15. 15 plus 4 is 19. 19 atoms total. Pause the video and try these ones out. I'm going to show you how to do numbers 1 and 2. Actually, I'll show you numbers 1 and 2, and then you can pause the video and try them on your own for the other ones, just to get some practice with it. This 2 applies to everything inside the brackets. What that means is we've got only 1 calcium here because there's no subscript. But this 2 multiplies everything inside the brackets. So that will be 2 times 2 for the carbon, which means we have 4 carbon. That's going to be 2 times 3 for the hydrogen. So that is 6 hydrogen. Yeah, I'm just going to put that there. And it's going to be 2 times 2 for the oxygen. That's 4 oxygen. Same for this one for strontium phosphate. This 3 only applies to the strontium, but this 2 applies to both the oxygen and the phosphorus inside the brackets. So we are going to have 3 strontium, 2 phosphorus, and 8 oxygen. So pay attention to whether or not there are brackets there. There seems to be a typo here, so for number 6, this 4 should be a subscript for the phosphate in iron 2-phosphate. This we're going to end off today. We're going to talk about ionic versus molecular compounds. And then we're going to spend the next few lessons naming them. But if you take a look here, atoms of different elements bond together to form compounds. There are 2 main types of compounds. We have neutral ionic and neutral molecular, what we're going to start with. This word neutral refers to having a pH equal to 7. pH equal to 7. That is a measure of how acidic or basic a substance is, and we'll talk more about acids and bases in a future lesson. But for now, we're going to just focus on ionic compounds and molecular compounds. Ionic compounds are going to be a combination of a metal, which they have abbreviated on the top as M, and a non-metal. So a metal plus a non-metal. At standard atmospheric or standard ambient temperature and pressure, these are going to be solid. They will conduct electricity when aqueous. conduct electricity when dissolved in water, which we'll use little brackets AQ. Blue and red litmus paper, that's a test for whether or not something is acidic or basic. It's a chemical property of these substances. Blue litmus paper stays blue, and red litmus paper stays red. Anything that is a neutral substance will have these properties. An example of one of these would be a sodium chloride compound. It's going to be solid, so we can give it the little S. The sodium here is our metal, and the chloride here is our non-metal. Molecular compounds are going to be a combination of a non-metal plus another non-metal. Sometimes you can have more than just two non-metals, actually often, but a non-metal plus at least one other non-metal. These can be solid, they can be liquid, or gas. It really depends on their size and what they're bonded to. The main defining feature compared to ionic compounds is that they do not conduct electricity, don't conduct electricity when aqueous. They are still neutral, so blue litmus paper stays blue, and red litmus paper stays red. And an example of this would be water, two nonmetals. H2O, which is a liquid, but then we also have other examples like glucose, which actually has 3 different nonmetals, and that's a solid, or you can have a gas like methane. Remember from your periodic table that metals are the ones that are left of the staircase, except for hydrogen, which counts as a non-metal, and these green ones are the metalloids. This right here is a little picture of a conductivity test. We'll do some of these in class, or I might demonstrate one if you are watching just the videos. But conductivity test commonly uses a light bulb, and if power can run through the circuit through solution, then the light bulb will light up, and that will tell you whether or not you have an ionic compound or a molecular compound dissolved in solution. This is an example of a litmus paper test. This particular substance is changing blue litmus red, so this would be an acid, but more on that later. If you take a look at here, you're asking yourself the question, are these compounds ionic or molecular? The question that you want to ask is there a metal? Is there a metal? Is there a metal? So the first one, calcium bromide, has calcium in it. It has a metal, so it must be ionic. But directly beside it, it's got just carbon and hydrogen. There is no metal, so this is going to be molecular. One thing to look out for. You're going to see these things in brackets. These are called polyatomic ions. There's one that kind of acts as a metal. The one polyatomic cation, NH4 plus, acts as a metal. That's not present on this page, but if you go to the previous page, when you're looking at the numbers of atoms within different compounds, this is an ionic compound. Yes, the chromium here acts as a metal, but if that wasn't there, there's some examples where it's not. This is still an ionic compound, but we'll talk more about that in a later class. For today, what I really want you to take away is that a metal plus a nonmetal is an ionic compound, nonmetal plus a nonmetal is a molecular compound, and how to read a formula to determine how many atoms of each element are in there. That's all for today. Next lesson, we'll talk about naming ionic compounds and building them and building their formulas.